All right, today we're going to do area and perimeter, and we're just going to dive right in with some review. Okay, so question 1, we've got this rectangle here. Use a calculator to find the area and the perimeter of the window. Let's do the perimeter first. Remember, perimeter is finding the rim, so we're finding the total length around the outside. So far we know 68 plus 32 is 100. So these two sides add up to 100. Well, here's another 32, and here's another 68. So what I have left is another 100. So 100 plus 100 is 200. And since we're measuring length, it's going to be 200 inches. Okay, next, let's find the area. Well, area, we have 32 going this way, and we have 68 going this way. So we're doing how many? 68 32s. 68 times 32. You can plug that into your calculator, or you can do it by hand if you want. I'd rather you just get it done, though. 2,176. Not inches. We're talking about how many square inches are in here. All right. Part B. The window's glass will be replaced. Which measure would be used in finding the amount of glass needed? Well, the glass are how many squares are inside, how much is inside. That would be the area. Part C, a silver wire will be placed around the window. We're putting the wire around the outside, so we need to know the length around the outside. That's the perimeter. Okay, question 2 is similar. I'm just going to go to part B and C. A chain will surround the lot. So we're putting a chain around the outside of whatever this rectangle is. So we need to know the perimeter. Part C, the lot will be paved. So we're paving the inside of this parking lot. So that's the area. Okay, question 3. Answer the question below. The perimeter of a rectangular garden is 296 meters. So it's 296 all the way around the outside of this garden. So I'm going to write the perimeter on the outside. Perimeter equals 296. If the length is 82 meters, what's the width? So we're trying to figure out our width. We know that that's 82. We know the width is on both sides. So let's figure out how much we have so far with both lengths. 82 plus 82 is 164 meters. So far we have 164 meters. We know there's 296 total. So that leaves us with 132 meters. Okay. Each side is not 132. We can't call this side 132 and this side 132. That'd be way too big. Since they're both the same, we're going to divide it by 2. Each side is 132 divided by 2, which is 66 meters. Okay, so let's make sure our answer makes sense. We have 66 plus 66 plus 82 plus 82. That should add up to 296. Makes sense. Okay, part B. The area of a rectangular window is 8,316 square centimeters. So that's the inside. So I should write that inside with the label. That's my area. I like to write the area inside the box or the rectangle, or if I'm doing perimeter, I like writing it on the outside. If the width is 84 centimeters, what's the length? Okay, well, we know length times width is 8,316. So 84 times L equals 8,316. Hey, look at this. This is a one-step algebraic equation. Remember when we did this? We want to isolate the variable, isolate the L, so I'm going to divide each side by 84. So the length equals 99 centimeters. Let's see if that makes sense. 99 times 84 should give you a number close to that. Yep. All right, number 4. Answer the question below. Write your answer in simplest form. A square has an area of 121 centimeters. What is the length of each side? Okay, so it's a square, and we know it's going to be 121 centimeters squared. So whatever this is times whatever this is equals 121. They're both going to be the same. So let's just put in a random number. Let's say they're both 9. Is 9 times 9 121? No. So we can try 10. 10 times 10, that's 100. Not there yet. Let's try 11. 11 times 11 is 121. So each side's 11. We haven't talked about exactly what this means, but over here is how you do that. The square root of 121 is 11. Okay, a square has a perimeter of 24 meters. All right, so each side isn't 24. How many sides? 4. So each side is 24 divided by 4. So each side's going to be 6. Question 5. Alan wants to paint a rectangular region of a wall with 1 layer of paint. Okay, please draw this. He has 28 feet of tape, so the perimeter is going to be 28 feet around the border. He is considering 3 regions with the width of 5, another one with the width of 6, and another one with a width of 7. Okay, so let's answer the questions below. So if the first one has a width of 5, we need to figure out what the other 2 sides are going to be. So far we have 10. 28 minus 10 gave us 18 left for both the other sides. Well, if it's 18 total, each side's 9. Let's do the same thing with the next box. 6 feet on each side for a total of 12. If we had 28 total, that leaves us with 16 feet for both the other opposite sides. So that means each one's going to be 8 feet. And the last region has 7 on each side with a total of 28. That leaves you 14 for both lengths. Well, again, that'd be each one being 7. So we got a perfect square there. Okay, so we can fill in our data. Fill in the table. Region 1, if the width is 5, the length is 9, because 9 plus 5 is 14. If the width is 6, the length was 8. 6 plus 8 is 14. Region 3, the width is 7, the length is 7. That adds up to 14 too. All right, now let's find the area though. I'm going to do this in a different color so you can see. The first one, 5 times 9, gave you 45 square feet. The second one, 6 times 8, gave you 48 square feet. And the last one, 7 times 7, gave you 49 square feet. All right, so which of these regions would require the most paint? The most paint. Is it going to be 45, 48, or 49? 49, region 3. Okay, here's a principle that will help you out with future problems. Let's try to erase some of this stuff. I'll just go down a little ways before we get to the next question. If we have similar perimeters, let's say all my shapes here have the same perimeter, whatever that might be. To maximize the area, the amount inside, if they all have the same perimeter, to maximize the area, we get as square as we can. Make the length and the width closer together, like a square. When you make your length and width further apart, you have a smaller area. A good way to think about this would be with fencing. If you have a square backyard, you need the least fencing compared to a really long, narrow backyard. Okay? If you had the same area. So, we're going to apply that quite a bit in math coming up here. That's just a concept. If you can understand that concept, it'll help you out a lot. If not, a lot of trial and error. Question 6. A rectangular park is 50 meters wide and 100 meters long. Okay, so it is not very square. It's pretty oblong. 50 meters wide, 100 meters long. Give the length of another rectangular park that has the same perimeter but a smaller area. Okay, like we said, if we want the same perimeter, we could either make it more like, if we make it a square, 75 by 75, then we're going to maximize the area. If we make it longer and skinnier, like 10 by 140, we're going to have a smaller area. It's going to have the same fencing. See here, this fence is 300 meters for the perimeter. This fence here was 300 meters for perimeter. And this fence here was 300 meters for perimeter. Because what I did is I just added those and doubled, added those and doubled, added those and doubled. So what would another length and width be? 10 by 140. All right, guess and check works for that, but also just applying that concept of maximizing area works too. All right, good luck.